Hello everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today we've got Hritik who has just completed the course Linux Basics for Robotics and he'll be giving us a presentation on that. So without any further ado, let me hand over the platform to him so he can begin his presentation. Okay Hritik, whenever you're ready.
Okay, thanks for the introduction, Desire, and it was lovely learning with you. So I'll just walk you through the presentation with all of others seeing that. Um, Most of my presentation would be on project, the project that is done on the course.
Mm-hmm.
So let's walk through it. The first slide says is part one, and part one of the project is basically launching project using Linux terminal. Uh, Using the command interface and just going through the nitty-gritties of Linux, like changing the directories, creating some, sourcing the file, how to use the ROS command. So that was a simple thing. We also did some simulation in part one using the commands that are mentioned in the course, and we ran it in simulation as well as the real robot using the teleop command. Part two is focuses more on creation of a new project using the Linux terminal, using the main commands like cd, mkdir, and all those to make the directories, then to uh, source the package, then to use ROS2 package command to create the project folder. And as mentioned, there are some more steps. Some says to remove the test files and all, and to source other files from the folder that is already present in inside your package. So I did that. So it's three file. I'll show you in the presentation later. And then again run the simulation to check the best file. Then to create a bash file to get the getters and setters of the robot. Getters are basically to get the information of the robot, that is using the LiDAR and all those things to get where the robot is currently located and how much distance far ahead is the obstacle. And then setters are basically functions to set the velocity or angular velocity of the robot. And part three is the most important part where you make uh, basically a bash file. A bash file is basically a predefined terminal file that you run, and it will run all the terminal commands without you actually typing anything because it's already typed in your bash file. And so, yeah, this is the main file. There is a bash file, similar bash file in project part two that you will run. So using that bash file, we have to create a new bash file. So without wasting more time, I'll move ahead to the main ROSJet thing. So just a minute. Uh, mm, okay, okay, yeah. Okay, so I think my simulation is already running.
Yeah, we want to see the real robot first, right? As always, so you can connect and then
Yes, sir. I didn't. Yeah, actually, I can't hear you. Wait. Yeah,
can you hear me now?
I will again run the simulation. It's okay.
Okay. Is my audio clear to you?
Uh, yeah. Now it's I can hear you. It's a bit low, but I can hear you.
Okay. All right. Let me just
I
go
will
ahead and
run.
repeat
I will
that.
just run again everything again
Okay. How is it now?
to show. Yeah, it's good now.
Okay. Yeah, I was saying let's do the real robot first so that we don't lose time.
Okay, sure.
Okay.
Okay, so just is it okay if I use this thing to run the commands because I have not saved the commands anywhere? I'll just be copy pasting the commands from this file. Is it okay?
Yeah, it's fine. It's fine. I will have to ask you about some
Okay.
of them that you're using though, because that's part of the knowing how to use the Linux terminal. But it's alright for the sake of speed. Yes.
Yeah. Yeah, okay. All right. So I have booked. Let me connect. So very first thing you have to connect to the small city lab. Then after connecting, we, we will just run the command of launching the real robot somewhere here. It's done. So there is a section called test real robot, and inside that you will find the command to run the law. This one. Okay. This is an error. I will get through it. I'll just again launch the real robot. So I can, yeah, live stream. Yeah, okay. So robot is here. And then as mentioned in our third part, we will run our codes. So this one. So this is this code, the robot interface PY. It's basically a ROS node, as far as I understand. I'm not an expert, but yeah, this ROS node will basically um, help us to use our getters and setters.
Mm-hmm.
Yeah, it's running. Yeah, so all good now. It has detected it's a real robot. That's good. Then again, we'll run our file that I created. So this is the file, obstacle avoider.bash. So this is the file. Okay, I've given the permission, so it's running now. You can see it's detecting everything. Let's one more. We have to run more. One more file. This one. It will give all the statistics like the position and velocity of the robot.
Mm-hmm.
Okay, so let's
Can you?
see.
Yes, we want to see what the robot is doing when the obstacle avoider is running, right?
Yeah, okay, okay.
Yeah. So I think maybe move your terminal down a bit so that we can be able to see that window. Yes.
Okay. Okay, just a minute. You can see the command line readings of the robot.
Mm-hmm. Yes, that's good.
Okay. Oh, sorry. Why it's not. I think it's stuck at one point. I don't know
Try
why it's
moving
not
it
moving right now.
with the joystick and the arrows, and let's see
Joystick.
if
Okay.
it moves.
Okay.
Okay. Okay, now it's available. Try again.
There is some error, I guess.
Don't worry about that window. I think
Okay.
let's do this.
Yeah, I
So
drew with the joystick. Yeah,
yes.
okay. Just a minute.
Uh,
I think I'll have to close the robot interface to run
no,
it with joystick.
no. You have to just drag the joystick to the arrow. Don't click the arrow itself. Drag the joypad in the center there to the arrow.
Arrow? You
The
mean
yes, click the center and
I
yeah.
used just click.
Is it not moving?
Oh, I did it, but it's not moving.
Okay, let's try this. Go in the terminal and run rows 2
Just a
run
minute.
teleop twist keyboard. Have you used teleop before?
Okay, yeah, I've used teleop. I'll use it
Yes,
from
let's try
this
teleop and
command.
let's see.
There is a teleop command here.
Mm-hmm.
Okay, I'm trying to move with the teleop.
Yep.
So these are the keys.
So just press I to see if it goes forward.
Yeah, I'm trying. It's not
It's
moving.
not moving. Okay, so
Yeah,
disconnect and
not
then
moving. I
connect
mean,
again.
it's not. I think last time I did it connected. Uh, there was no such error in the first one.
Yeah, it can happen sometimes. So, but normally
Yeah,
disconnecting and reconnecting should
and
work.
the RWS also opens immediately and shows everything.
Yeah. Okay, try reconnecting again. So, just click connect.
Okay, wait a minute. Wait a minute.
Alright, so let's try the joystick first and then tele.
Okay, okay, okay. It's
Okay, now
moving
it's
now.
moving. Yeah. So, yep.
Okay, let me get it to the center. Okay, and then run my commands again.
Mm-hmm. Let's start with obstacle
Okay.
avoider, right?
Directly, yeah, I'll just do that.
Mm.
Just a minute. I'll first have to run this right. Yeah, it moved.
Okay, now, okay, sure, much better.
Okay, now it stopped. It stopped because the threshold was less than that. As mentioned, it's 0.3 meter in the code.
Mm-hmm.
Again and again.
We still want to see what it
So
does, so.
it's, yeah, I got it. All front block. That means front left, front right, on front, everything is blocked.
Mm-hmm.
So it's scanning right. I don't know why it's not rotating. It should rotate. I think.
Should be turning left because that's what it's saying.
Yeah, it should turn left. Yeah, it's not. I think I'll just increase the sleep time.
Did this happen? Did this happen to you
It
any time
happens
before?
sometime, but it also moves sometimes.
Mm-hmm. And you found what the issue was?
I just said you the sleep time, because if I keep the sleep time more, it turns a lot.
Okay, so you were trying to retune that to the perfect
Yeah,
value. Okay.
but it runs perfectly in simulation. I don't know why it doesn't run here.
It doesn't. Yes, the simulation is different. You won't get a one-to-one transference, right? There will be things that are different
Yeah,
in
yeah,
the real environment.
yeah. I get it.
That's why we always say test it both in simulation and the real robot, and then you can be sure what you need to do to make it work in the real environment.
Yeah.
Okay, you can make those changes and let's see if it
Yep.
changes anything.
Okay, do that. Recall my sleep times to 3 to 4.
Yeah, maybe you'd have to stop execution and run it one more time.
Okay, yeah. So I'll close all the files. So so this is the file that I wrote. It's the same file that it was given us in the project part two.
I think what I,
I just
let's
made
let's
some.
do this right. So you said it's something to do
Yeah,
with the
okay.
sleep time.
Yeah, okay.
So let's do that
Yeah,
first
okay.
and see that it works. Otherwise, you
Okay,
will run
fine.
out of
I
time.
will
So
just. Okay, okay. So some sleep times. I'll just change every sleep time to 5. 5 would be much. 3. Let's do it 3. Okay. Let's run it again. Check with Teleop first once again. And now it's not initializing.
let's give it some time.
Yeah, okay. No, I think it won't initialize. I will have to disconnect and do it again because I've tried this.
And it
I'll do
happens.
that again.
Okay.
Yeah, it is happens. I have to disconnect and then do it again.
Yeah, your session is going to lapse now. You've got about a minute. So
Yeah.
automatically disconnected. All right. Can you see if you can get the next slot? Just check for me.
think I can get because it's free. Yeah, okay. Wait, I'll just again do it. Do it.
All right. So
Mm-hmm.
so long. Let's
And this
see
is,
a demo in the simulation, and then you can run us through what's going on
yeah,
and
yeah.
explain
Okay,
the
okay.
code. Yeah.
Okay,
We
okay.
have to see that it works first.
So,
Otherwise, there's no point in
yeah, yeah,
looking
yeah,
at
I
code
get it.
that's not working as expected. Okay.
Yeah, yeah, okay.
Okay.
I just run the simulation. In the morning, I think I just run the simulation before joining you. So what's running?
You did test on the
Robot,
real robot, right?
Indian robot.
I think I asked you
Yeah, I
this
did
first
test.
time.
Yeah, yeah, I know. I did test and it moved. I don't know what's because
Yeah, because
the first
we
time I did
must.
it, the Arvis was running fine, like this Arvis thing. Now it's not showing. I don't know why.
Yeah, well, what I was gonna say is we must not undermine the value of doing a real robot test, right? So your evaluation and
I
every
know.
other
I
person's
understand.
evaluation is based on the real robot. So if you get it to work in the simulation, that's like 10% of the
Hmm.
story. The whole idea of doing this presentation is to show that it works in the real environment, right? That's why I was
Okay,
asking you
okay.
that question a couple of times.
Oh, sorry. Yeah, disconnected. Yeah, it's already disconnected. So we can run the simulation. This is for the simulation. So
Mm-hmm.
I can do the same thing. Live. Not this one. Use R5. So let's jump into the simulation. See, this is the Arvis graph. This is basically what the robot senses. This is the simulation.
Okay, it stopped, but that's before the threshold. What's going
No,
on
no,
there?
it's moving. Yeah.
Is it? Okay.
Okay.
Click
Oh, yeah, it's moving.
threshold.
I think uh the decision loop is long,
Okay.
so that's why it takes time. So basically, it's what's the name suggest. It's a knife
Yeah,
file.
it's naive obstacle avoider, yes. But it must be able to rotate 190 degrees out of the
Yeah,
way, either or, right?
yeah, I know, I know.
Yeah,
Yeah, it
so
should, it should.
I am looking for this initial initiative, right? Does it tend to avoid an obstacle? Does it tend to
Yeah, yeah, I
avoid
get it.
something that's in front of it? That's the basis of what I'm looking at here.
Hmm. Okay, okay. I think now we have changed the sleep time. So yeah, it did rotate it. It's rotating, but I think it might rotate more than it should.
Okay, no worries. Let's see that first.
Okay, so as you can see on this,
Yeah, in simulation would be good too. I think we want to see both.
okay, let's just keep it side by side so you can see both.
Yeah.
Yeah, now see. So it, I think, avoided the block. Static now. Once again, it's turning.
Okay, that's good. At least it managed to avoid that with that block. Okay, so
Yeah,
I think
yeah.
now we are into the next 30-minute slot, so you can connect now.
Hmm.
Just stop execution
Okay,
here, and then let's connect to
okay,
the robot.
sure. Just do that. Okay, so it's done. Let's connect to the real robot. Should I change something? I think I should do it because it didn't work last time. Should increase the angular velocity. Yes. No, I think don't.
If these values worked the first time, right, or
Yeah,
the
it
what
works. Yeah,
the time you connect to the real robot,
yeah, and
what could be making them not
yes,
connect?
yes.
What could be making them not work, right? Can
No,
you at
it's
least explain
maybe.
that to me?
Um, It's receiving the command. I think it's the decision loop, but it worked that time. I don't know why it's not working right now. Because it's stuck. It's stuck on the same. It comes to the same point and gives the same value. Like in the loop, it comes to the same point and then it gives the same decision. And but yeah, I mean, this thing is not working. It's not rotating because it should rotate, but it's not rotating.
Okay, so the changes that we've made now, do you think they're going to fix that issue?
Right now,
Yes.
I will trying to do. I
Because
didn't
you.
do anything. I just run the same thing, just
And it.
change some sleep time,
Yes.
and it
And it
did.
didn't help. Alright, because we're running out of time, so I was
Yeah, I
giving
get
you a
it. I get
leeway.
it.
I
It's
wanted
okay.
you to get it to work first so we would see that it works, right? At the moment,
Okay.
it's not doing what we
Okay.
expect it to do, right? And
Okay.
if you have no direct direction where you want to go to fix that issue,
Okay. Mm-hmm.
unfortunately, we have to end it here.
Okay. So we'll do one thing. I'll just run the command one last time.
Okay, let's
If
see.
it works,
Mm-hmm.
yeah, and otherwise we'll end it. No worries.
Okay.
So I think this is okay. And this file also. Statistics as well. So it's running linear,
Mm-hmm.
distance cover zero point 0.7 meter, but it's not rotating. I don't know why.
Try to pick a window configuration that's not going to allow you to switch chop and change. It'll be easier for me to see as well.
Okay, I just yeah, see. On front block, choosing right. Date set parameter main front. Mm. No, it's not working. Okay, and then I think we'll just end here nowadays.
All right, all right.
Sorry for your time, mate.
It's all right. Sorry about that. It's part of the learning process, right? So let's wrap it up here,
Okay.
and you just hang around for me on Zoom, okay?
Okay, I'll just send that. Oh,
All right. All right, everyone. This was Hritik's presentation, and I would like to encourage all those of you who want to try this course to do so, and you can also come and showcase your project, demonstrate what you've learned, get it work on the real robot, and then you stand a chance to get a certificate from us. We do this for all the courses that we offer certification on. So on our platform, you will see that they would have a certificate provided. All right. Until next time, I encourage you to keep